Okay, so now look at another example. Find the volume of a solid generated by revolving the region enclosed by the triangle with vertices 4, 0 right here, 4, 6 right here, and 7, 6 which is right here. Okay, so it turns out this is a triangle, right? This is 90 degrees. Um, so you're trying to do the revolving of the region, and then it turns out, you know, if you draw this, and then if you're starting to do the revolving, right, and then you're gonna have it's kind of like a cone, but you cut bottom and then also cut the up, and also you make the inside empty, right, if you do the revolving. So if we want to using the Washer method, notice that this is going to be the smaller radius, right? And this guy from here to here, this part, so maybe I call this is small r, this is called the big R, okay? And then remember the idea, little r, capital R, right? So we're trying to find a area for a cross section, and then we integrate it there. But one more thing you need to be a little bit careful is, this is we are doing the revolving about the y-axis, right? So we're gonna integrate it with respect to y. Actually, it's gonna be from 0 to 6, right? To 6 up to here, to 6, right? So in other words, the structure of the integral we'll set it up is going to be from 0 to 6 something dy. Okay, dy. So this is very important. So the next is we need to figure out what is the equation, right, for this line, because this one there's nothing wrong with that. This is just x equals 4, right? So this line, it's a vertical line. And then how do we handle this? Well, we got those 2 points, right? So you can very easy to figure out that in fact the slope is going to be 6 minus 0 over 7 minus 4, which is going to give us is 2, right? 2. And then you can set y equals 2x plus b, and then if you plug into for 0, and it turns out that, so it's 0 equals 2 times 4 plus b, so you're going to get that b equals -8 easily. So in other words, the equation of this line is going to be y equals 2x minus 8. But keep in mind, when we're trying to use this revolving about the y-axis, when I'm trying to find the larger radius from here to here, that's the distance, I need to write x in terms of y, right? So in other words, if you solve x in terms of y here, so y equals 2x minus 8, then y plus 8 equals 2x, and then x equals y plus 8 over 2. So that's okay. So once we get that, and then you will see that you're going to have pi times capital R, right? The larger R squared, which is y plus 8 over 2 squared minus pi times, actually it's a 4 square, right? So you can do something to split this. Is going to be y squared over 4, right? And then you're going to have, what I'm trying to do is y over 2 plus 4 square. I'm trying to expand this. It's going to be y squared over 4 plus 2 times y over 2 times 4 plus 4 squared. And then that gives us 4y plus 16, right? So it's 4y plus 16. And also, don't forget we have this 4 squared here, so it's not 16, so it's minus 16, and then dy. Hence, we'll have y squared over 4 plus 4y only, right? And for this one, it should be very straightforward to evaluate it, right? So we pull pi out, so you're going to have y cubed over 12, right? And then plus 2y squared, right? I think that's right. Okay, and then from 0 to 6, so all you need to do is just apply pi, we have 6 cubed over 12 plus 2 times 6 squared, right? Yeah. So we can, so this is, after you simplify this, it's going to give you it's 18. Yeah. And then plus 2 times 36, which is 72. And then this was 90 pi. Okay.